So in this video we'll be going over some questions involving the differentiation of polynomials. So in previous video I just pretty much told you and showed you that if you take the first derivative of any polynomial to the n power, all you got to do to differentiate that is bring the n down the front and subtract n by 1 in its power. Okay? So in the previous video I established this formula, and yeah, it works for polynomials and stuff. So this video is just purely going to be on questions involving polynomials. As you can see here, there's a lot of questions I'm going to go through this video. So this video is just practice, pretty much. I feel like the best way to learn math is just to start practicing the problems. So I'm just going to have this formula up here in the corner, and we're going to get straight to it. So we're going to start with question 1. If you want to have a go at question 1 by yourself, feel free to have a go at it. Alright, question 1, we're differentiating this, so we're going to bring the 4 down the front. So we're going to have, that's going to be equal to 4 multiplied by 8, x, and you're going to subtract 4 by 1. So 4 times 8, that is 32, I think. 32, yep. 4 minus 1 is 3, so x to the 3. So when you differentiate x to the 4, 8 times x to the 4, you get 32 x to the 3. So that's what happens when you differentiate this, you get this. Okay? Hopefully that makes sense. That 8 is very bad looking. Alright, let's have a go at question 2. Alright, this one is a bit different, so if you want to have a go at it, feel free to pause the video and have a go. Alright, so what we're differentiating is 5 over x squared. Now how are we going to do that? That doesn't look like this form up here. Well, it actually does. Just remember your index laws. If you have 1 over a, that's the same as a to the negative 1. So we can rewrite this as 5 multiplied by x to the negative 2. See how I did that? So I applied this index law to this, and I changed the way it looked. It's the same thing, it just looks different. And now we can differentiate that. So if we differentiate 5 times x to the negative 2, we just do the same thing as we did before. We bring down this down to the front and subtract it by 1. It doesn't matter if it's positive or negative exponents, this still works. So we're going to go negative 2 multiplied by 5, x to negative 2 minus 1. So that's going to be negative 10 out the front, so we're going to have equals negative 10, x, negative 2 minus 1 is negative 3, so negative 3. Simplifying that, that's going to be negative 10 over x to the 3. Okay, so that's what happens when we differentiate this, we get that, alright? Alright, let's have a go at this next one, number 3. So if you want to have a go at number 3, feel free to pause the video and have a go. Alright, same thing as before, 1 over t. We're just going to use our index laws and we're going to change the way it looks. That's the same as t to the negative 1, alright? So if we're taking the derivative, d dt, all we're going to do is bring this down the front and subtract by 1 up here. So that's going to be equal to negative 1 t negative to the negative 1 minus 1. So simplifying that, we're going to have, my computer's not loading, negative t to the power of negative 2. Okay? And simplifying that even further, we can say it is negative 1 over t all squared. Okay? Cool. Alright, feel free to have a go at question number 4 if you're feeling confident. After all, I'll just be showing you how to do them. Alright, so question 4, same rule as before. Going to bring this down the front and subtract 1 up here. So if we go derivative of x of 8x to the 7 over 4, that is 8 multiplied by 7 over 4 multiplied by x to the 7 over 4 minus 1. Okay, so let's handle this part here first. So 8 multiplied by 7 over 4, 8 is the same as 8 divided by 1, and if we multiply fractions, we multiply the top and the bottom. So the way we do this is we go, that's going to be equal to 8 times by 7 divided by 1 times by 4. 8 times by 7 I think is 56, so the top of it is 56 and the bottom is 4. 56 divided by 4, using my calculator because I don't know off the top, is 14. Okay, so the front of that is going to be 14. Now we're going to have to do another bit of math, so we're going to go 7 over 4 minus 1. So we're doing this part here now. So this is going to be a bit tricky. The way we do it is we're going to change how the 1 looks. So do you remember, if we have a fraction, we're adding or subtracting them, they need to have like denominators. Well, also recall that if you divide any number by itself, it's 1. So negative 1 is equivalent to it's not loading, is equivalent to negative 4 over 4. Because 4 divided by 4 is 1, times by a negative is negative 1. So this is true. So we can replace our negative 1 with negative 4 over 4. So we go 7 over 4 minus 4 over 4. 7 minus 4 is 3, so we're going to have 3 over 4. Okay? So simplifying this whole thing, we're going to have, when you differentiate 8x 7 over 4, you're going to have 14 x times by x, if my pen loads, times x 3 over 4. Okay? See how I did that? Now I'm going to make this whole thing a lot smaller so I can fit in my working for the next question. Okay. Alright, cool. So that's the working for question number 4. If you don't have a go at number 5, feel free to pause the video and have a go. Alright, 5. It's exactly the same thing as before. So all we're going to do is bring this down the front and subtract 1 up here. Okay? So when we go the derivative of x to the 3 over 5, all divided by 6, that is going to be 3 over 5 multiplied by 1 over 6, x to the 3 over 5 minus 1. Alright, let's deal with this first. Alright, so multiplying fractions, multiply the top of the fraction and the bottom of the fraction together. So that's going to simplify to 3 multiplied by 1 is 3, divided by 5 times by 6. So 5 times by 6 is going to be 30. So 30. You can simplify that even more, because if you go 3 divided by 30, you can take out a common factor of 3 from the top and bottom. Because if you have, this is the same as the top here, so that's the same as 3 times by 1, and the bottom here is the same as 3 times by 10. Okay, so you can just cancel the 3. You're not really taking out. It's more so cancelling, taking out what's common in both of them. Okay, so that simplifies to 1 over 10. If my pen works, there we go. Alright, so that's the front of the derivative. Now we're going to do 3 over 5 minus 1. We're going to use our fact that we know before. So we're going to change negative 1 to negative 5 over 5, because the bottom of the fraction is 5. So 3 minus 5 is negative 2, so we're going to have negative 2 over 5. So I'm going to just move all this. So if you find the derivative of x to the 3 over 5 divided by 6, you're going to have 1 over 10 x to the negative 2 over 5. Okay? Or you can simplify that even more, just not have the 1 there at all, and just have the whole thing over 10. Okay? Cool. Let's go on to question 6. So if you don't have a go at question 6, feel free to pause the video and have a go. Alright, so we're finding the derivative with respect to u, so I've just changed the letter. As you noticed before, I changed the letter when I had a t in there. So du over u. So find the first derivative of u with respect to itself. Recall that u is just the same as u to the power of 1. So when we diff that, we're going to bring the 1 down the front and subtract the 1 up here. Okay? So how do we do that? well, first of all, if we diff this, we bring the 1 down the front, so that this front here is same as 1 times by 1. U to the power of 1 minus 1. That whole thing's going to be 0. And recall, if you have a to the 0, any number to the power of 0, that's the same as 1. So d over du of u is just 1, because that whole thing there is going to be 1. So it's going to be 1 times by 1 times by 1. Okay? Cool, I hope that makes sense. Alright, feel free to have a go at question 7 if you're feeling brave. If not, just wait for me and I'll solve in a sec. Alright, question 7. dt over the square root of 2 over the square of 2t. Okay? Recall that the square root of any number, okay, is the same as the square root of a is the same as a to the power of a half. Okay? So we can change basically how this looks on the inside. So if we go the square root of 2t is the same. So the square root of 2t is the same as 2t all to the power of a half. That looks a lot easier to differentiate, doesn't it? Okay, so all we got to do is move that down to the front and subtract 1 up here. Okay, so 2 times by a half. Well, if you have double something and you're halving it, you only have 1 of something. So the front 2 times by a half is 1. So you can have t, and then a half minus 1 is just negative a half. So differentiating this whole thing simplifies to t to the power of negative a half. Okay? Right, that's a lot easier to simplify. Alright, cool. And let's get on to question 8. Find the derivative of 1 over the square root of x. So if you want to have a go at that, feel free to have a go. And if you don't, just wait for me and I'll begin solving it. In these this video is mainly it's mainly like a problems time of video. If you want to know where I learned how to do all this from, there's a previous video on my channel where I explain what a derivative is, and then I explain why we use this certain rule instead of first principles. So if you haven't seen that, I would recommend going to see that straight away, because you'd probably be very confused if you were just a viewer on the channel watching this stuff. Okay? Alright, so let's just get straight into this one here. Alright, so we have 1 over the square root of x. So we can change 1 over the square root of x is the same as x to the power of negative a half. Okay? All we got to do is bring this down the front and subtract by 1. Alright? So we're going to go negative a half x negative 1 minus 1. So negative a half minus 1. We can change how negative 1 looks. Negative 1 is the same as negative 2 over 2. So we'll go negative 1 over 2 minus negative 2 over 2. That is the same as negative 3 over 2. So the first derivative of the square root of x, 1 over the square root of x, is equal to negative a half x to the power of negative 3 over 2. Okay? If you had any questions at all in this video, please leave some questions in the comments, because I won't know if you're struggling with certain topics at all if no one talks to me, pretty much. Alright? So if you have any problems or quarrels at all with anything that I've been doing, just please let me know in the comments, and then I'll get straight to you. Alright? I also realized I think I've done question 7 wrong. So we're going to have a go at question 7 again, because I think I've gotten it wrong. So sorry if that was a bit inconvenience to you. So I'm going to try question 7 again. Alright, so we're just going to rub it out and take it from the top. Alright. So I think I rushed it a bit too much and I made a silly little error in there. So the square root is acting on the 2 and the t. So if we remember our index laws, if we have ab to the power of m, that's the same as a to the m times by b to the m. Okay? So if we simplify this and change this, we go 2t all to the power of a half. That a half needs to act on the 2 and the t. Okay? So that's equivalent to 2 to the half times by t to the half. Okay? So if we were to differentiate, oh whoopsie daisy, my rubber is not working that well. So if we were to differentiate this now, so we went d dt over 2 to the half, t to the half, and bring the half out the front, we're going to have the square root of 2 over 2 t to the half minus 1, so that's going to be negative a half up there. If it rubs out, so sorry for the inconvenience. So that is, this here now is the correct answer for question 7. Sorry if I confused you at all. I'll leave something in the comments hopefully to tell you that initially I got question 7 wrong, but luckily I realized that just in time. Okay. Alright. The rest of it though is correct. Okay. The rest of the questions have been correct. So let's have a go at question 9 now. So question 9 is the same process as before, but it's a couple of things at once, alright? So have a go at question 9 if you're ready for it, and then I'll solve it. Alright, so same thing, we're going to apply our differential law to this, to this, to this, to this individually, okay? For some reason my pen isn't behaving that well today, so it's taking a while to switch over. So first line, if you want the differential of this, you're going to have 3 multiplied by 5, x to the power of 3 minus 1, plus 4 multiplied by 2, x to the 2 minus 1, plus negative 3 multiplied by 1, x to the power 1 minus 1, plus the differential of a constant is 0. Okay, so we can get rid of that. I explained in the previous video why it's 0. Basically, if you want the rate of change of something that doesn't change, there is no rate of change pretty much. So that's why it's 0. And I show mathematically why it's 0 as well. So this is going to simplify to 15 x squared plus 8x minus 3. Okay? Alright, that's question 9 completely solved. If you want to have a go at question 10, feel free to have a go. Alright, so du d du over 1 plus d du over negative u. Differential of a constant 0, so this whole thing goes bye-bye. U, negative u, same as power of 1. So bring 1 down the front. U to the 1 minus 1 is just going to be equal to negative 1. Okay, so that's question 10 solved. Alright, question 11. This one looks a bit more challenging because we have very weird powers pretty much. But it's the same principle as before. So feel free to have a go at question 11. So we're going to bring so we're going to have our 3 over 2 multiplied by 4x to the 3 over 2 minus 1 plus a half multiplied by 12 x to the half minus 1. Okay, I'm going a bit faster because I feel like I've explained the rule enough, and I think people will get annoyed if I explained it for every single problem. It's just the same rule that we've been doing this entire video, so it's just this same rule up here. Okay, and I'll just go back down to our problem. Alright, simplifying 3 over 2 times by 4. Think of that as 4 over 1. Multiply the top of the fraction and the bottom of the fraction, so you're going to have 12 over 2. 3 over 2 minus 1. That's the same as 3 over 2 minus 2 over 2. So that's going to simplify to a half. Okay? So you're going to have x to the half plus a half times by 12 is just the same as dividing by 2. So half of 12 is 6. So you're going to have 6x. A half minus 1 is negative a half. This can also simplify to 6. So I'm just going to rub that out. Oh, if my pen loads in time. Yep. So it's going to be simplified to 6. So that is the correct answer for question 11. Alright, question 12, our last question of the video. Alright, find the differential of this pretty much. Alright, so if you want d, oh, why is it that in red? I think my computer is overheating again, that's why it's lagging quite a bit. So if you want d dt over the square root of t minus 1 over t, we're just going to change how the inside looks. So square root of t is the same as finding the derivative as t to the half minus t to the negative 1, okay? Applying our rule, we're going to have a half t to the half minus 1 minus 1 multiplied by negative 1 t to the negative 1 minus 1. This whole thing is going to simplify to a half t to the negative a half. So we're going to have a half t to the negative a half. A negative times a negative is a positive, so it's going to be plus t to the negative 2. Okay, that's all the questions solved in this video. If you have any questions, Phil, leave some in the comments. I apologize for getting question 7 wrong, but I've gone back and fixed it in the video. Sorry if you initially got stumped by that or that confused you. For that, I'm sorry. If you did learn something, please subscribe and share this with someone who's just learning calculus. Anyway, thank you.